Okay, here's we're gonna go over these homeworks from section what was it, 10-7? Okay.
Why do you do your zeros like that?
What? How do I do my zeros?
I start at the top and go around.
I start from right there. I start from 11 o'clock. I did record that. All right. Except for me. What don't I do? 2 is this, right? X is this. 12 and 6.
Oh my goodness!
Is that everything? And okay, solve for X, right? All right. Well, let's see. You take the outside times the whole thing, right? You guys watching? You guys had all these questions. Now you're talking to each other. Come on. I'll just go on to the next lesson. So I take the outside times the whole thing. And that equals this outside 2 times this whole thing. What's the whole thing?
14.
It's 14. So what was it? Was it the algebra that messed you up?
Got 10 wrong.
Right. Yeah, that's what I meant by the algebra. All right. So it's the quadratic formula you don't like?
I love that thing.
Yeah, I think it's very handy.
It's so much easier than factoring stuff.
It is very handy. Watch. So what is the A? Is 1. What is the B?
6.
It's 6. And what is the
Negative
C?
28.
It's negative 28, right? So you need to know which one's the A, the B, and the C. So let's come over here. Let's write it down. X equals negative B. I wrote it yesterday, right? So you should have written it down. B squared minus 4AC, and that's over 2A. So it's just plug and chug, right? Yep. So let's see. Negative B means the opposite of B. Well, B is 6, so the opposite of 6 is negative 6. Plus or minus.
I keep forgetting it's 2A. I always think
Yeah, I thought it was just 2. That's why I messed up.
All right. B squared, 6 squared is 36, minus 4 times A, which is 1, times C, which is negative 28. And that whole thing is over 2 times A. Well, A is 1, so you still could have got it right, even if you wrote the equation over 2, didn't you? Because the A is a 1 anyway, so it wouldn't have made any difference. But technically, it's this. All right, and then we just simplify this thing. Negative 6 plus or minus square root. That's plus, right? So what's that? 56, 112, is that right? 36 plus 112 is 148. Is that what you got inside of there?
Yeah.
Did I do the math right?
Yeah.
I don't know.
Over 2. All right, now let's use a calculator for this. It's just 2 equations. It's just negative 6 plus the square root of 148 over 2. And then there's a second one. It's negative 6 minus the square root of 148 over 2. So it's like 2 separate things. It's like 2 separate things, except it just makes it look a little nicer by putting in the 1. I don't know. I mean, look, if we go over a few of these today, absolutely. I mean, it's fair game. I mean, we did it yesterday, right? It's not that hard. It's just plugging stuff into a formula. So what do we get? We got negative 6, right? Negative 6. Let's do the plus first. Plus the square root of 148. Oh, did I? All right, let's start again. Negative 6 plus, that's better, the square root of 148. And I'll get an answer for that and divide that by 2. And it's 3.08, which rounds to 3.1, right? It says rounded nearest tenth. So it's 3.1. So 3.1. Is that a valid answer for this?
Yeah.
Sure, because it's positive, and this is a positive length, isn't it? Probably the other one's negative, I would guess, right? So if you just don't want to waste your time, I probably would have just stuck with 3.1. But let's put in the other one. So it's negative 6 minus the square root of 148. You get that. And right now, I know that it's going to come negative anyway, right? So I don't even have to use that. But anyway, I'll divide it by 2. And you get about a negative 9.1. Negative 9.1. So those are your 2 answers. But you're not going to use this one. Why can't you use this one? because it's a negative number, and you can't have a negative length of that segment right there. So you use the positive one, and 3.1 is your answer. You don't like that? Why not? It's ugly looking, but I don't know. It's cool looking. Makes you look smart, doesn't it? But it's really not that hard, right? That's what I like. I like when they make you look real smart, but then they're really not that hard, you know. All right. So is that what we had trouble with most of these? Is just putting it into this?
That is not what I had trouble.
It's not? Okay.
That was I got
Did
that.
anybody, somebody write these down so I don't have to keep going back up to the top of these again. So what did we just do?
19,
We just
20,
did
21,
11.
15.
Can you remember that?
Yeah.
Okay, 15, 19 to 21. Okay, we'll do 15, then 19 to 21. I still probably don't remember, so
I
remind
know.
me. All right, so what's
15.
15? Okay. Read what? I'm going over it right now. Then you can.
I wasn't here yesterday. Can we do this homework again tonight?
It was actually on YouTube last night. All right, 15. That's that cake problem. She's serving a cake at a party. The dimensions of the remaining cake are shown below. What was the original diameter of the cake? All right, so it's a circle.
Are you far sighted or near sighted?
Like whatever. I don't know.
You're not using the glasses and like reading it.
I have bifocals, but when I'm too far, when it's dark like this, I'm kind of far away. It's hard to read, so I take them off. But see, if I take them off right now, it's completely blurry. I can't see a thing until I get to there, and then it's perfectly clear. Isn't that weird?
Yeah.
It's getting old. Getting old stinks. Stay young. Stay young. Not that you have any choice. Not that you have much choice. Let's do this dumb problem. Here we go. You can't see that color? How's that? And then that doesn't go through the center though, does it? That 12 looks like it goes about right here, doesn't it? Yeah. And then the 9 looks like it goes to here. Let's just change color of that one. Okay. All right, everybody good with that?
Mm-hmm.
And this is, and it's perpendicular, and this is 9, and this whole thing is 12. That whole thing is 12. And we have to find the original diameter of the cake, which means we got to go from here all the way down to here. Correct? Alrighty. Well, let's do this. Why don't we just extend this down all the way, huh? Because that's what we're trying to find anyway, isn't it?
Yeah.
Okay. What do we know? Now, did they say
You don't know what the
the dimensions of the remaining cake are shown? What's the original diameter? You kind of have to make a little bit of an assumption here, I think.
I don't know.
I think you have to assume this actually goes through the center,
Yeah,
don't you?
Yeah.
I think that's the only way you can do this, if you assume that it goes through the center. Yeah. So what do we know about that? What do we know about? Well, they tell you it's a right angle, right? So let's see. What can we do? We got to find this little bit right here, don't we? Yeah. Let's we got to find this little bit right here, don't we? From here to here. And if we find that, we can add it to the 9. That's your diameter. Okay, so it's just a matter of finding this. All right. So this is 12. It's if it's, let's see. Yeah, it's 6. Okay. All right. Well, let's look at this. This whole thing is 12, so this is 6 and 6. I'm trying to give a reason why. What did we say? There was something about a diameter being perpendicular to a chord, and it bisects the chord. Remember that one?
Yeah.
That was a while back. So let's get rid of this 12. That's just kind of ugly and in the way. And let's make this 6 and this 6. Okay? And what are we going to do here? Remember, these are chords that intersect inside the circle. So we don't even have to do any of that stuff. Just, we don't have to do that stuff. Okay? What do we have to do? Remember, you got 2 chords that intersect inside a circle? That was the very first thing we did yesterday. What was true about it? From here to here is 9. From here to here is X. This is 6, and this is 6. So the product of the segments, right, equal each other. The product of these two segments. So this is 9, this is x. So if I multiply them together, I get 9x. If I multiply these two together, I get 36. X is 4. Is that the answer? Or, I mean 13, right? 13 is the answer. Yeah, because x is 4. You want to find the original diameter, so from here to here would be 13 now. No. Right, but they asked for the original diameter. Right. Yep.
Okay, 19.
Okay. 19?
Mhm.
All right.
Do the same thing for number 14 though.
Okay, these are the ones I did not understand.
Okay, so these are the hard ones?
Yeah.
Alrighty. 19?
You're just doing 19, 20, and 21.
Okay, the last 3.
Yep.
I think I might be able to remember that. Here it goes. Alright, let's see what's going on here. It looks like you got a tangent where that 10 is. And then that looks like it goes through like that. And this thing at the point of tangency cuts across like that. Does that look right? Alright, let's stick some numbers in there. This is 6. This is B. This one is 8. What's that? A. From there. This is 4. And that's 10. Wow. And you're trying to solve for A, I guess, right? A and B? A and B, right. Okay, well, you do have chords that intersect inside the circle, right? But you got a little problem here, though, don't you? If I go 6A equals 8B, I got 2 variables, I got 1 equation, I can't do that. So I got to find something else, right? Well, let's look at that tangent. Yeah, do you remember that thing? I've got a tangent and I've got a secant, don't I? So I think I could probably find A. Can I? Yeah, I think I could find A, sure. Because watch, I'm going to use this tangent, the 10. I'm going to use this secant, this 4, this A, and this 6, okay? You remember what the deal is? You take the outside of the secant, right, and multiply it by, let's see, the outside of the secant times the whole thing, right?
Yep.
Which is, what?
10 plus A.
10 plus A, isn't it? Right? The whole thing. Take the outside times the whole thing. So the whole thing, just add up all, they give you like 3 parts of it, right? The 6, the A, and the 4. So if you add them all up, that's a 10 plus A, or A plus 10. So that's the outside times the whole thing. What does that equal on the tangent? 10 squared. And now you just solve for A. Yep. So 4A plus 40 equals 100. Subtract 100, that's 60. Divide by 4, that's what, 15? So A is 15. There you go. Now that you know A is 15, you can find B pretty easy.
How would you figure out that 4 is A plus 10? You said A.
Because it's the outside of the secant. The rule we did yesterday is you take the outside part, the outside segment, times the whole entire secant. So 4 is the outside part. What's the whole entire one? Well, it's the 6, the A, and the 4. 6 and 4 is 10 plus the A.
Find B.
No. We got this 10 because of 6 plus 4.
Find B, would you just do 6 times 15?
Yeah, on this one, it's 6 times 15 equals 8B. Divide by 8, and you got your answer. You can do that yourself. It's that where it intersects inside the circle. It's the one we just did on the other
So
problem.
what is B?
It's 8 times B. It's the product of the segments. Listen, it's the product, which means you multiply, right, of the segments of the chords equal each other. So this chord right here is broken up into 2 segments, 8 and B. So the product means you multiply them together, so you get 8B. That equals the product of the other 2 segments of the other chord, right? So you multiply them together, 16 or 15 times 6, right? And then you divide by 8 and divide by 8, and you do the math and you get whatever that is. Whatever. 11.25, or round it to 1 decimal place. 11.3. Make sense? Okay. 20. All right. Let's see what that looks like. Okay. Circle. And let's see. Looks tangent down the bottom, doesn't it? Now, basically, what they say is if it looks tangent, it's tangent. Okay? Does that look tangent? Okay, what? Let me do this. Right there, right? And now let's just kind of move that to there. Okay, that looks tangent. All right, and then you got a secant going from here to here. Oh, it goes outside, doesn't it? And then it goes from here down to that point of tangency. All right, there we go. That looks pretty. Let's use this green color. This little bit is 2, and R, and 18.5, and 16, and Q. Is that a Q? And that's a 15. Is that everything? 16, R2, yep. And you got to solve for the two variables, R and Q. Alrighty. Let's see, well, we got a couple things going on, don't we? We've got a tangent and a secant here, and we've got two secants right here. So why don't we do the tangent and the secant, this tangent and secant, the 15 and the Q, 16 and 2. It's basically what we just did on the other problem, isn't it? Everybody see that? So let's do this. It's the outside. I know my Q's are weird looking, but that's how I do a Q. Q times what? The whole thing, right? Take the outside times the whole thing. What's the whole entire thing? 18 plus Q, right? Let's see. Are we sure about that? Yeah, that's right, isn't it? Yeah, that's right. So it's Q times Q plus 18. Oh, this comes out quadratic. All right. Equals, actually, it's not that bad because it equals what? 15 squared, right? So it's the outside times the whole thing, whoops, right, equals the tangent squared. And let's see what we get for that. We get Q squared plus 18Q equals 15 squared is what? 225, so yeah, let's just put minus 225 equals 0. Because it was positive over here, and I put it to the other side so I could set it equal to 0. Because when we do this quadratic equation, you have to have this stuff set equal to 0. So I just did that in one step. Is that all right? Okay, and quadratic formula? Yeah, it's not even write it down. Let's just put the numbers in. So it's negative 18 plus or minus the square root b squared. What's 18 squared? I don't know what that is off the top of my head. 18 squared. Thank you. So it's 324 minus 4 times a, which is just a 1, times c, which is negative 225. That's over 2a, which is just really 2, isn't it? Because the a is a 1. And now it's just a matter of doing all that stuff. What's that? That's 450. That's 900. So 900 plus that is 1224. Is that right?
Yeah.
Look at that. Doing stuff in my head. So it's negative 18 plus or minus that over 2. Now I can't do that in my head, but you plug that in and you get what you get. Do the plus first. Oops. Do the positive first. So it's negative 18 plus, okay, let me just do it. Square root of 1224. That equals that. Divide that by 2. Why did I do what? Divide that by 2, and it's 8.49 or 8.5, right? 8 point. Now the other one's probably going to be negative, so I'm not even going to worry about that one. I'll just use the positive one. It can't be two different things, can it? It's only got to be one thing, so that's positive, so it's got to be the 8.5. Yeah. So this is, what I say, 8.5? All right, now you got to find R. Well, do the same thing, but you're using this secant right here, the one we haven't used yet, and we'll use this secant, the one that we have used. Got it? Let's do this in a different color. So let's do this one first. Take the, do I have enough room up here? Watch. I take the outside times the whole thing, which is just r plus 18.5 equals, I'm going to have to scooch this over a little bit. Well, now you do. Now you're big kids now. You can handle it, okay? So anyway, that's this one right here, and this is going to be, what? The outside times the whole thing. What's the whole thing? That's 18 plus 8.5, which is what? 26.5? Everybody see how I got that 26.5? It just added up that whole entire secant. And now you just solve for that. Might be a little ugly. Have to use a calculator a little bit, but y'all love your calculators, right? So r squared plus 18.5 r. What's that? What's 26? 53. So we're going to put minus 53 equals 0. Plug it into the calculator. I'll let you do that. There you go. Put a 1 in for the A, right? Put a 18.5 in for the B. Put a negative 53 in for the C. Plug and chug and get an answer, right? Yeah, there'll be times where it's not 1. Yep. But in these, they just happen to be 1. So. And, I don't know, what'd you get? 1.8?
Yeah.
My professor in college used to do this. He would say, he put a little lightning bolt, and he says, there's all your work, okay? And then you would say, that's your answer right there. Because that's just work. You can do that part. All right? 1.8. That looks like a lightning bolt to me. Be very afraid of the lightning bolt. All right, enough of that. Let's do another one.
21. Last one. This one.
All right. Looks like you have another tangent. About right there. That looks kind of tangent. Okay, and then from this point, you got a secant here and then a secant down here. Alright, let's stick some numbers in now. This little middle part right here is 9. This outside part is D. This outside part is 11. This is 15. And this is that C? Yep. That's it, right? Okay, well, let's take a look at these. It's supposed to be tangent. It's not very pretty, but you get the idea. We'll just say it hits right there, okay? What do you want to do? Do you want to use that tangent and secant? This tangent D and this secant C and 9? No, because you got two variables. Right, so let's do this. We could do two things. One or two ways, right? We could find the D by using this tangent and this secant, couldn't we? You couldn't? You could. Or you could use this this secant and the secant, right? So you could either use this top tangent and this bottom secant, or you could use the two secants. And either way would work. Which one do you want to do? Let's do the tangent and the secant right there. So what would that be? That would be d squared equals, what's this? This is 11 times the whole thing, right? The outside times the whole thing. What's the whole thing? It's 26. Right? So d squared equals, what's that? That's 286, isn't it? Did I ever show you how to multiply by 11? A two-digit number times 11? Never showed you? It's kind of easy. Now I'll do it right now. Watch. 26. Look. 26 times 11. So what do? You put the 2 and the 6 here. Add the 2 up. Stick it in the middle. That's how you multiply by 11 with two digits. Isn't that cool? Yeah. Sometimes it gets a little more complicated than that when you have to have not a remainder, but you have to carry and stuff. But for a lot of them, then you just add the 1 here, and then you just, like if this came out to 10 or more, you would add the 1 here and stick the second number in there. Anyway, that's kind of nice. So what do you do with that? Is it 17 exactly? Yeah, that looks
No,
familiar.
it's 16.9.
That's not? Oh, 289 I think is 17, isn't it?
Yeah, so you are 17.
Okay. I don't know, what is it? 2?
Yeah.
So it's the square root of 286. 16.9. What does it say to round it to? Nearest tenth? Yeah, just 16.9 then. Yep. So that's D. So that was pretty easy. And then do C. What would you do? I would use these two secants right here. So let's do that. Let's do this top secant. So we take the outside. Let me do this in a different color. We take the outside times the whole thing, which is C plus 9. And that's going to equal the same thing here, right? The outside times the whole thing, and that's 26. Pretty easy, isn't it? 9C plus 81 equals, there's that 286 again. Subtract 81 from both sides. So 9C is equal to 205, am I right? Divide that by 9. And does that come out to 22.8? Should, if you round it. 205 divided by 9. Yep, 7 rounds to an 8. So we're good right there. What's that? You can't do 17 now after we did all that stuff? Come on. I've given you enough. I can't do every. I can't walk you through every single problem. I've given you enough. If you
I tried to plug it in and everything, and I couldn't get the right answer.
on which one?
I can't get the right answer either.
20?
20 for R. I can't get the right answer.
Oh, so you didn't like the lightning bolt?
Well, maybe I didn't plug it in right, but then
All right, let's do it. Negative b, so it's negative 18.5, right?
Yeah.
Plus or minus the square root of b squared. Let's put that number in right now. 18.5 squared. 342. Let's use the whole thing. 342 point. What was it? 225. Okay. Minus 4 times a, which is 1, times c, which is negative 53. And then that's over what? 2 times a, which is just 2. Alright, so it's negative 18.5 plus or minus square root. This is a plus in here, isn't it? Because minus minus. So it's 342.25. Let's try that again. 342.25 plus 53 times 2, that's 106. 212, right? Plus 212. Because minus minus. Okay, it's that. Did I do that right? Oh, I gotta take the square root of that number. What am I doing? Oh, all I'm doing is stuff inside of there, right? Okay, so I'm just gonna write that. That's all I'm trying to do. Is 554 point what? 25. Okay. And then that's over 2. Now I'm gonna stick that in my calculator. I can do that part, right? So it's. Did you get something different? Alright, we'll look at it. Plus the square root 554.25 divided by 2. 2.5, is that not what they said? They said 1.8. You got 2.5.
I got 2.5, and then I kept doing it, and I was like, I'm doing something wrong.
Well, I mean, they've been known to be wrong, but I've been known to be wrong too, so let's just double check it. So it's the outside times the whole thing. You got 1.8? 18.5 equals 2 times that whole thing.
Yeah, Q equals 9, not 8.5.
Thought we got 8.5. I said it was 9. So when you put in a 9, it probably comes out to 1.8. It's probably what it was.
So you wrong?
But they said round it to one decimal place, didn't they? To the nearest tenth.
Wait, so what's the answer?
So I like my answer better, tell you the truth, because I'm keeping stuff in the tenths. And you still got a 1.8 using an 8.5?
Yeah, and for my
Well,
equation,
what did we do wrong
I
here
got
then?
r squared plus 18.5r minus 36. I'm not sure how I got 36, but that's what I got. Like,
Oh, you know what? Oh my goodness. That 8.5 shouldn't have been added to this. You're absolutely right. That's where we messed up. Because it's only from here to here. It's only the secant from here
oh my
to
goodness.
here. Okay? And from here to hitting the circle, right? Yeah, did we do that on the other one too?
No, because we got the right answer on the other one.
Yeah, that's, you know what? When I was thinking of that, I think I even said something about, yeah, because let's see, when we did this, so we did the 18 here, q times, see, this wasn't right. This shouldn't be 8.5, should it? Because it should just go to here. So it should be q times, this should be a 16. This right here should be a 16. Let's see if it comes out a little bit better. See, that should be a 16 right there, shouldn't it? Because I remember saying something when I did that. I was like, and then I just kept on going. And then that should work out for you. I'm not going to go do all the stuff, but so Q probably is closer to 9 then. So let's do that again because we're going to use a 16 instead of an 18. Yeah, that'll definitely make a difference, right? So it's negative 16 plus or minus the square root of b squared. What's 16 squared? 16 squared is 256. I should know that number, but minus 4 times a. Well, we know a is 1, right? And c is negative 225. And that's over 2. Let's see if that gets it for us. Square root. Let's see. Twice that is 450. That's 900. 900 and that is 1156, right? Did I do that right?
I don't know.
Pretty sure. Check. Okay. And so now let's give this a shot. So it's negative 16 plus,
Yeah, it comes out exactly.
good, the square root of 1156. Oh, good. It's 18 divided by 2, and that is 9. So it's not rounded to 9. It's an actual 9. And so that's where we're going to get that's where we'll get the 1.8 from.
Anyway.
All right. So good. I'm glad we did that because,
Now I'm very familiar with the quadratic.
well, good. You should be. Well, that's going to help you when you do that in Algebra 2 next year because you're going to be doing a lot of quadratic equation next year. So you need to be, have it in the back of your mind, know how to use it. All right. So sorry about that. That was my fault. I should have never done that whole entire thing because it's only to the circle. It should only be to there. When I say the whole thing, right, it should only be to there, not all the way to another outside point because it's only to the circle. It's the secant. When we do these things, it's a point outside the circle, and it only goes the secant until it hits the other end of the circle. You can't use that part right there. Yeah, and this right here should be just 2 times 18. Right, so this is wrong as well. So this should be 2 times the whole thing, which is 18, right, equals, and then, is that number still right? Yeah. And then it would be r times r plus 18.5. Okay? Now it should come out to 1.8 if you do it. We good? So did you correct all those while we were doing it? Should have. I did a bunch of them. Okay.
I understand it now.
Well, now we're officially 2 days behind this week. But because we were supposed to, is it bad? It's not good to be.
10-8 is really
2 days
easy. It's just
behind.
one formula.
Yeah, that's a good idea. You can blame Trevor for that one. All right. No, I'm not gonna give you homework over this week. All right.
Be quiet.
All right. That's it. I am finished. Have a good weekend. Anybody here going to prom? No prom people. I'm going.